we're going to talk about titration curves and the equation that goes along with this. Now, when we're talking about titration curves, we're talking about acids and bases. So what a titration is you are taking a certain concentration and volume of an acid and titrating it with, so putting in a strong base into the acid so you can reach the equivalence point. Now, the equivalence point is where both acid and base are present in chemically equivalent amounts. When this happens, you will reach a pH of 7 because that's when it is neutral. So your acid, we all know that starts at a low pH. So if you look at this titration curve, we're starting at a very low pH and we're going up until we reach our equivalence point. While doing this, we're adding an amount of titrant. The titrant we're going to be dealing with, and is usually the case but not always, is our base. Okay, so we're adding base to this acid, making the pH go higher. When our pH shoots up at 7 pH, that is our equivalence point. For a strong acid and strong base, it's always going to be 7 because that is neutral. And then if we keep going in our curve, and so we're keep adding more and more base, we will be ending with a very high pH because now the base is taking over and there's less hydronium present and more hydroxide present. So we're only doing strong acids and strong bases, so we know that the equivalence point is always going to be at a pH of 7. Now, there's an equation that goes along with this. This equation is MAVA is equal to MBVB. It's very similar to our dilution equation because now we're kind of diluting an acid with a base. So instead of M1V1, instead we're going to use MAVA, which means the molarity or concentration of the acid times the volume of the acid is equal to MBVB, or the concentration of the base times the volume of the base. In typical titration equations and problems in labs, okay, you do not know the concentration of the acid that you are dealing with. So whatever is getting titrated, okay, so that means whatever is sitting there and something else is going into it, okay, you don't know the concentration of that, and that's what you're looking for. So let's do a few of these practice problems. How much 0.20 molar NaOH is needed to reach the equivalence point when using 15 milliliters of a 1.5 molar HCl? So in this problem, we know the concentration and volume of our acid, but we're trying to figure out how much base is needed to put into our acid. So, like I said, we're using MAVA is equal to MBVB. So here we can set up one of our charts. So instead of using 1 and 2, here we can use acid and base. So we have acid, base, molarity, volume. How much 0.20 molar NaOH. NaOH we know is a base, so we know the concentration of that, so that's 0.20 molar is needed. So we're trying to figure out the quantity of NaOH, and that's going to be its volume. When we're using 15 milliliters of a 1.5 molar NaOH. So here we're solving for VB, so we're going to divide both sides by MB so we can get VB by itself, and we're going to end up with MAVA divided by MB is equal to VB. Now we're just going to plug in the numbers that we have. So the molarity of the acid is 1.5 molar. The volume of the acid is 15 milliliters. Divided by the molarity of our base, which is 0.20 molar. We plug that into our calculator. And we find out that we are going to need 112.5 milliliters of our base in order to titrate 15 milliliters of a 1.5 molar HCl. Next, it says, using the titration curve, so we're going to be using that titration curve over there, what concentration of HCl is being used when titrating 20 milliliters with a 0.15 molar NaOH. So again, let's set up our chart. So we have our acid and our base, polarity, and volume. So it says, using the titration curve, what concentration of HCl? HCl we know is going to be an acid, so we're looking for the concentration of our acid. When titrating 20 milliliters of HCl, so we know our volume, that's in milliliters. And our base, we know the concentration is 0.15 molar. Now, we knew that our titration equation is at the equivalence point. This problem didn't give us a volume of our base, but we're using this titration curve. So what we're going to do is we're going to go to the equivalence point and find the volume of the base. So to me, this looks probably like 18. So let's say we have 18 milliliters. So now we're solving for MA. So we're going to divide both sides of our equation by VA. So we get MA is equal to MBVV over VA. We're going to plug in our numbers. So we have a 0.15 molar times the volume, which is 18 milliliters, and then times the volume of our acid, which is 20 milliliters. So we're going to do 0.15 times 18 divided by 20. And it's going to tell us that the concentration of our acid is a 0.13, or rounding up a little bit, 0.14 molar solution.